Okay, so let's look at another one here. So we've got a uniform metal rod. It's kept at 25 degrees on one end and 85 on the other. And the temperature of the rod at any position x follows the differential equation. So as we move x, the temperature changes. So t is a function of x. And what we're told is this function, the second derivative, is equal to 0. So find the tx of the function. What's the temperature as a function of x? Well, that's called the second derivative. Okay, we know this is our second derivative. If my second derivative differentiates to 0, that means that the first derivative must have been a constant. I'll call c. So it changes. The first derivative, the change in temperature of change x, is a constant value, so it changes linearly along this line. Okay, so if we know that, then we can just say, okay, well, we know that halfway is going to be halfway between 25 and 85, which is, I think, 55 degrees. Okay, but we can also calculate this. Okay, so we're told that that's our c. Okay, and what are we told? We're told at x is 0, call x is 0, y is 25 degrees, and when x is 50 centimeters, the temperature is 85 degrees. I can't really put that in here because I could actually figure out the slope and just say that's c, because the slope here would be 60 divided by 50, or 6 over 5, or 1.2. That would be my slope. That should be my constant here. But we can also figure it out this way. So I'm going to, again, anti-differentiate this and say that that's going to be cx plus, k, another constant. And I have two variables to solve for, and I can just use my 2 points. At x is 0, the temperature is 25, and that's equal to c times 0 plus k. The k value then is 25 degrees. Okay, and I can solve at t of 50, I know that it's c times 50 plus k, which is, I already solved for 25. So that's going to be equal to 85 degrees Celsius. So if I want to solve for c, I'm going to 85 minus 25 is 60 divided by 50, and there I get my slope of 1.2. Okay, so I get my linear equation. T as a function of the position x is going to be 1.2, that's my c, times x plus 25. Okay, so this is a function that changes linearly along this line, so it's just constantly changing temperature. So we can adjust this problem and say that, well, this is a composite, and now the temperature does not change linearly. It changes differently depending on where you are on here. So closer you are, it changes very little, I think, and the further you get, I think it changes quite quickly. The temperature